Hello everyone, I'm Alessio from the 36 PhD cycle in Urban and Regional Development, and today I'm going to present you my research on the use of stable water isotopes in hydrology that, we will see, can be considered as the fingerprints of water. So we can start. We know that the water molecule is composed by 2 atoms of hydrogen and 1 atom of oxygen, but pay attention, these atoms are not all the same. In fact, we have some atoms like hydrogen or oxygen 16 that are lighter, and others like deuterium or oxygen 18 that are heavier. Now that you know this, I can introduce the definition of isotope. An isotope is each of 2 or more forms of the same chemical element that contain equal numbers of protons but different number of neutrons in their nuclei, and thence differ in relative atomic mass but not in chemical properties. As you can guess, we can combine these isotopes in different ways in a water molecule, so that we will have some water molecules that are lighter and others that are heavier. The main consequence is that when water evaporates, lighter molecules preferentially rise, while when it rains, heavier molecules preferentially fall. And depending on this repeated phenomenon of evaporation and condensation, precipitation water will have a different isotopic composition. In particular, calculating the ratio between heavier and lighter isotopes, it is possible to understand the root of water. Take in mind that these ratios are highly dependent from temperature. This is why precipitation isotopes show a seasonal cycle in which we have heavier molecules during summer and lighter molecules during winter. Interestingly, same water isotopes show a seasonal cycle too, but it is a lagged and damped version of the precipitation signal. This is because the system under study, that is the catchment, acts as a filter. We can use different mathematical techniques for modeling its behavior for understanding the velocity of the water molecules moving through the system. In fact, isotopes are atoms of the water molecules, so they move with the water molecules. For example, from amplitude to seasonal tracer cycles, it is possible to estimate the so-called water fraction, that is the fraction of runoff with transit time of less than roughly 2 or 3 months. Starting from this background, I elaborated the following research questions that are guiding my research. So, how does a catchment store and release water? How does ion water fraction vary under different hydroclimatic conditions and why? What is the seasonal origin of stream water? Furthermore, this research has different fields of application. In fact, it is really important for better understanding problems like catchment dynamics, fluid generation processes, pollutant susceptibility, nutrient loss, water resource management, and obviously we have to study all these problems under the current climate change scenario. So this is in brief my research, and thank you for your attention.